Hello geometry students, welcome to the continuing series of videos. And in the last video we talked about finding the area of a regular hexagon, and there was a nice special case there. This time we're going to work on a pentagon, and it's going to require a little bit more work from us because it's not so simple. But the same strategies still apply, wherein we take this shape and we cut it up into 4 or 5 triangles. And in this case you have to be careful because these side lengths here are not the same as these lengths here. Okay, that last time it was only true, it was special for a hexagon. So I'm going to draw a bigger version of this so that we can work on this a little bit more clearly. Okay, so we know that this length here is 20. And this is the central angle in here, and that's 360 divided by the number of sides, which is 5. So this comes out to 72 degrees. So we want to find the area of one triangle and then multiply it to be 5 times, multiplied by 5, because we're going to get a total of 5 triangles out of this. Okay, so we just want to find the area of one of these triangles. And to do that, well, I'm going to copy that out here. We're going to need to find the height. Okay, so we already know that the area of this thing is equal to 1/2 the base, which is 20, times the height, okay, whatever the height is. So if we draw this line down here, we'll call that the height. And now I'm just going to take a look at this smaller triangle here to help us find the height. So if we cut and we just cut out this section here, well, one thing that we know is that this length here gets divided in half because this is an isosceles. So this length here is going to be 10. And this angle in here, remember that it was 1/2 of the central angle. So the central angle is this big one, and if we cut it down here, then we have a smaller triangle, smaller angle in here, and that's going to be exactly half. So we now know that this is 36 degrees. Okay. And if that's 36, then by the triangle sum theorem, this is going to be 54 degrees. Okay. So we can find the height pretty straightforward. I'm going to say that this is the tangent of, you can either use 36 or 54, it doesn't really matter, but I'm going to use 54 just because it's a little bit easier. Tangent of this angle is equal to the opposite divided by the adjacent side. So 10 times the tangent of 54 degrees is equal to the height. Okay. So now substituting back, I have that the area here is equal to 1/2, and we're talking about the big triangle now, the base, which is 20, times the height, which is 10 tangent of 54 degrees. Okay. And now you just take this and type it into a calculator, and just be careful that your calculator is in degree mode. Otherwise, none of this will work. So 0.5 times 20 times 10 times the tangent of 54 degrees. And that's equal to 137.638. Now keep in mind that we only have, this is the area of the triangle here. Okay. We want to find the area of the entire thing, of the entire pentagon. So I'm going to write it down here. The area of the pentagon is, well, just 5 times this number. Okay. So times 5, and I get, this is approximately 688.2. And there's no units here, so I think I'm just going to leave it right like that. 688.2. Okay. There you have it. We found the area of one pentagon, of a regular pentagon, with a side length of 20. Okay. Now for the perimeter, I actually jumped straight to area this time. But for the perimeter, this one should be pretty straightforward. The perimeter is, well, 20 times 5, because this is 20, this is 20, this is 20, and this is 20. So the perimeter is just 5 times 20, which is 100. Okay. The area took a little bit more work there to figure it out. Okay, so you have a couple more problems here. Number 5, I'm going to tell you to try on your own. I'm going to stop here, and I'm going to create another video for number 6. Actually, yeah, for number 6 and maybe number 7.